Alright, so let's dive into it. Let's get into Chapter 1, Energy Analysis and Awareness. So let's talk first the most important thing, energy efficiency. What is energy efficiency? Well, energy efficiency should not be confused with energy conservation. The less energy consumed to produce the work required, the greater the energy efficiency. All of our equipment that we work on in the heating and cooling world is rated on efficiency. More precisely, how much energy is this piece of equipment going to use, and we want to ensure that we're utilizing as little energy as possible with this piece of equipment. The reason being is our grids are ever evolving. With the demand of electrical usage, we're constantly getting new electrical toys, gadgets, gizmos that are really draining the grid. And we don't have the infrastructure currently to support all these different nuances. And so because of that, we're looking at other alternatives, lowering the grid, looking at different energy types, and so forth. And so in this case, with the energy efficiency, we can look simply at the largest appliance that draws the most energy in our home, which is our air conditioning system. Some places they do have heat pumps, but to keep things simple, we're just going to call everything an air conditioner at this moment, or the outdoor unit. Here we have a couple of examples, right? Our first example over here is a single stage air conditioning system. Everybody in the class should be very familiar with this. You've probably worked on some form or other of this type of equipment in the labs, right? And we all know that this equipment turns on, gives us cooling, and it shuts off. Something that we've brought into the lab recently is the Mitsubishi systems. Some of you may be familiar with these, some of you may not. They operate off of a different principle completely, all right, and we're using inverter technology. So what is inverter technology, right? I mean, we have different shapes entirely between the two units, but let's go ahead and let's discuss inverter. Well, if we look at this graph here, we'll see that in cooling mode, a traditional air conditioning system was going to follow this black, we'll just say slash line. And as the slash line starts to increase, that is our temperature. Our temperature starts to go up. Our air conditioning does come on. It will run for a certain period of time until it meets the set point, right? Once it meets the set point, the temperature will continue, or the equipment will eventually turn off, and it continues to repeat this cycle. So we get this wave pattern, right? Very similar to the sine wave that we incorporate with electrical. The difference being is now with an inverter, we're speeding up and slowing down based on demand. So we have a lot less smaller peaks between everything, and what ends up happening is we actually have a lot less energy consumption from the equipment. So inverter technology is really starting to take the place of traditional air conditioning systems. It's more energy efficient, it's quieter, it's more effective, it has the availability to speed up, slow down, so now we can actually hit larger targets, or we can slow down. As we go throughout this class, we'll start to talk about load calculations and how those impact equipment sizing principles. But think of it this way really quickly. Our equipment is designed for 95-degree days, right? And we want to maintain generally about 75 degrees inside of our space. And how often do we actually have 95 degrees constantly outside in our area? The temperature generally fluctuates. And so if we have a system that or a home that requires 18,000 BTUs on a 95-degree day, that's great. However, as we get to 80 degrees or 75, where we still need the air conditioning to turn on, we have the availability to slow down and speed up with an inverter. Unlike a traditional air conditioning system, we would just be stuck, right? We would just be oversized for that space. So there's a lot of benefits that we'll definitely discuss in the future here in regards to inverters, how they impact everything, and how everything really works. So we understand what energy efficiency is. Now let's go ahead and talk about energy conservation. Energy conservation is an effort to reduce the amount of energy needed to operate a device or process, or even eliminate it. So going back to the inverter equipment that we were just talking about, we're trying to really conserve energy, right? We're trying to minimize the amount of energy that we're utilizing for heating, cooling our home, right? So the more that we can save, the better off we're going to be, right? That means that we're not going to put as much load onto the electrical grid and have potential issues, which we're going to discuss here in a little bit. So there's a few different ways of increasing efficiency. The first one is maintenance. Real simple, something that we're all going to be trained to do as technicians, is to go out in the field. And it doesn't have to be a furnace system. It can be all kinds of things. It can be commercial equipment. It can be chillers. Regardless, we need to maintain the equipment. We have moving parts. We have things that need to get greased or lubed, or we want to make sure that the refrigerant level is topped off. If the refrigerant level is not where it needs to be, we're going to have a decrease in performance, and that means that we're going to have electrical consumption, which in turn leads to, guess what, inefficient equipment. So maintenance, big part of ensuring that equipment is running properly, and that way we're not really wasting energy. Sometimes we just have to replace equipment, go with something a little bit more advanced, more modern. There have been some big changes in the HVAC marketplace over the course of the last 5 to 7 years here. More importantly, we've had a transition to different refrigerants that we're using. Now we're using A2L refrigerants, which are partially flammable. I'm sure you guys have learned plenty of that, but the reason we switched over to A2L stuff, well, was because the GWP was too high, the global warming potential. So the global warming potential basically means that we are emitting a greenhouse gas into our atmosphere, and that leads to a temperature rise throughout the world, right? And we want to see less of that, and that's why we're trying to be a little bit more energy conscious, more sustainable throughout everything that we do. Replacing equipment, we're going to use less energy, we're going to use less natural gas. Believe it or not, in 2028 there is a mandate by the government that everything needs to become a 90% furnace. So everything is switching over to being more energy efficient. Now, you don't necessarily have to agree with these principles, but this is what's happening, right? We want to do our parts to abide by different guidelines and different laws that are being given to us, right? The other thing that we can do is we can install a digital control. ecobee makes a really good thermostat, very reliable piece of equipment, lots of data points. You can do so much with this thing, so it's really great thermostat. I definitely recommend, if you're going to be installing any type of smart thermostat connected to the Wi-Fi functionality, so forth, to install an ecobee. There's other thermostats out there. Everybody has their own little preference. It just seems to be a good industry standard, as ecobee is generally one of the most reliable, best quality thermostats out there. If you really want to geek out, you can look at energy usage data points. You can do all kinds of things on there. So the nice thing about these smart thermostats is they're looking at not only just your temperature, but they're looking at your home, how it's performing. We have so many different data points. Believe it or not, in these units, first off, there's actually a little infrared sensor that's built into them right at the bottom left corner here. And what it's doing is it's actually sensing to see if people are walking past the thermostat. Let's just say, you were watching a movie, you got into the, I don't know, Game of Thrones or something, and you were sitting there doing a movie marathon, a show marathon for about 6 to 8 hours, and you're being very sedentary. Well, your thermostat's going to sense that, hey, you know what, nobody's home. And if nobody's home, then why do we need to heat or cool that space, when it's not needed? And so then it may shut the equipment down or lower the temperature because, hey, we're going to save some energy when nobody's home. So if you do have a smart thermostat, whether it's an ecobee or a Nest, you always want to make sure that you're walking past it every so often, waving your arms or so forth. If it does sense that people aren't walking by it, it will potentially shut things down. There's different settings inside there to reconfigure it, but ultimately what it's doing is we have options of controlling things, different set points. We can put schedules in there, so if somebody's not there, let's just say we have a commercial building and we don't have customers in that space or whomever, between the hours of 5 p.m. and 8 a.m., well, guess what? We can reduce the temperature down a few degrees, and that may be quite a bit of energy savings that we will accumulate throughout the course of the year. Another option is to install an energy recovery machine or some type of energy recovery device. In this case, we have what's called an ERV, energy recovery ventilator, and what it's going to do is it's going to take in outside air and bring fresh air into the space. Commercial spaces do require a certain amount of fresh air, just for sanitary reasons, right? And we have a bunch of people that are inside of a space. If we can't circulate that air, well, people are going to start to get sick. So we have the ERV that helps bring that fresh air in. However, if it's the middle of winter and we have a bunch of cold air coming in, well, that's going to take a lot of energy to heat that up, right? Or we're going to be blasted with some subarctic weather sometimes. So the energy recovery ventilator will actually transfer the outgoing heat content that's in that air, mix it in with the incoming, and now all of a sudden the air is more tepid, right? It's not going to have that big temperature difference, that big fluctuation. It can also transfer humidity as well. So now all of a sudden we're not going to have dry air. So energy recovery ventilators, they're really great pieces of equipment. A lot of new homes built with the tight construction that they have don't allow for breathing, and that's important, because if we have gaps in our home, we're going to have heat, we're going to have energy escaping. So a lot of these different gaps are sealed off, and with the gaps being sealed off, we don't get fresh air coming in. So that's why we have systems like this installed into new construction homes, or any type of homes that are sealed off with insulation and so forth, like spray foam insulation, making, like, for example, attics, conditioned spaces. So let's get into sustainable energy, right? So there's different types of sustainable energy that we do have, right? But first off, what is it? Sustainable energy sources will not be depleted in a time frame relevant to the human race. Solar, nuclear, wind, geothermal, and water are sustainable forms of energy. Basically, what it means is that, hey, we almost have an endless supply of this type of energy, right? The wind's never going to go away. We're not going to stop the wind. We're not going to stop the sun. We're not going to stop the water from moving, right? We can try, we can do different things. However, we're always going to continue to have this type of energy that we can utilize, right? Then we have non-renewable energy. That non-renewable energy comes from resources that can't be replaced once used up, like coal, oil, natural gas, and uranium. These formed over millions of years from ancient plants and organisms. Once we burn them, they're gone forever, and they release greenhouse gases that harm the environment. So going back to the A2L stuff that we were talking about, right? A2L is lowering the GWP, which basically means that we have less greenhouse gases going into the environment, right? Our predecessors had a higher GWP, or global warming potential, that allowed more heating to occur throughout the environment. So that's why we made that switch. Yet again, over here, looking at the diagram, we've got just a few examples of the different types of energy that we just can't replace. Once we burn it, we use it, it's not coming back. One of the byproducts of it is greenhouse gases, or pollution. So we want to minimize as much of that as possible, or try to utilize clean energy. We then also have bioenergy, right? Bioenergy, or biomass energy, is power created by burning or converting organic materials like wood, crop waste, animal manure, or food scraps. These materials store energy from the sun, and when processed, they can produce electricity, heat, or fuel. It's renewable because we can keep growing more plants. So it's actually probably the best of both worlds, right? We have wood, and we plant a tree, and then once the tree matures, we're able to chop it down and use it for whatever resource we need. We have garbage. We produce all kinds of garbage. The garbage emits different gases, crops, alcohol, right? We have different types of alcohol that we can utilize. We have ethanol and different landfill gases. So all this stuff can be burned, utilized to make things move or work, electricity. The only downside is some of this stuff, when you do burn it, yes, it does start to pollute. It does create issues with our environment as well, right? I don't know if you guys remember, but some of the Canadian wildfires that were coming down into our area, and it was really affecting the performance, our air quality outside. Some people were having issues breathing. They weren't allowed to go outside, or had to wear masks, or so forth. So there's different pros and cons to all these different types of energies, right? And it's going to be up to you if you get into a building somewhere to determine what's the best source for you, right? It depends on how much money you have to spend and what you guys are really trying to do. And that leads us to our carbon footprint, right? Our carbon footprint is the total amount of carbon dioxide and other greenhouse gases released into the air by your activities, like driving, using electricity, heating your home, or buying products. The bigger your footprint, the more you contribute to climate change. So the more products you use, the more things that you're utilizing, well, then you're going to have a larger carbon footprint. We start to have large corporations that generate a lot of waste, and a lot of them have started to lower the amount of waste that they're producing. And so they're going to energy-friendly means. They're going to solar panels. They're going to wind turbines. They're doing everything that they can to minimize the impact to the environment. And with a carbon footprint, believe it or not, you can actually buy or even sell credits. So you want to, what they call, try to be carbon neutral. So carbon neutral basically means that for all the different pollutants that you're putting out into the atmosphere, you're doing the equivalent of removing that in some fashion. So maybe you've emitted 1 ton of carbon dioxide, and now you replace it by maybe recycling 1 ton of plastic waste that you have. And so now all of a sudden, maybe your footprint is lower. Some companies, they will actually sell and buy carbon footprints. So one company, because they're so energy efficient, they have excess based on the size, and so they can turn around and sell that carbon footprint to somebody else, and then they can use that to say that, hey, they are carbon neutral. What it all boils down to is that we all generate waste. Whether we realize it or not, there's always some type of waste that we are producing, emitting, doing something that we just need to get rid of, right, through our just daily lives. And what ends up happening to most of it is they ends up going to the landfill. And so we have these giant landfills that are sitting there, right, with all the garbage and junk that we utilize or don't, right? Well, it's actually not terribly a bad thing. There are ways of actually generating energy from that. And then one of the things is we have methane. So as the landfill starts to break things down, all the different products that we have in there, one of the byproducts is generated as methane. It's a gas that we can use for energy. We can utilize it to power turbines. We can have the energy used to supply gas, right, for our homes, so that way we can cook with it. We can use it to power vehicles. We can use it for arts and crafts or industrial. So there's so many different facets that we can utilize methane for, that really makes it sort of not a terribly bad thing. Ultimately, what we want to do is we want to be good to the environment. We want to recycle. I'm sure you guys have heard this before, maybe in grammar school, right? We've got the reduce, reuse, recycle campaign. We're going to use less products that are out there. Instead of using 10 grocery bags, maybe we can stockpile all of the stuff into reusable grocery bags. If you guys are shopping at Aldi, they don't even provide you with bags, so you got to bring your own. Or you're in the city of Chicago. City of Chicago charges for bags now, and that's not necessarily a good thing. So it's reducing. We're reusing our bag. We're going to recycle anything that's of waste, or any type of plastic waste, or cardboard, or anything like that. It all has an impact on our in our environment. We have the natural greenhouse effect. Basically, the sun is coming in, it's shining its rays down, it bounces off the earth, heats it up, and then it just goes back into space. However, if we do have the greenhouse gases, well, there's this little bubble, this barrier that surrounds Earth. And while it's surrounding Earth, we end up getting all this heat that gets trapped in. It's almost like a little blanket on top of everything. And as the sun starts to generate this heat, the heat has nowhere to go, and it gets trapped. And what does that mean for us? Well, we start to generate a higher surface temperature, which starts to affect all kinds of things, not only life, but so forth. Now, another way that we can be good to the environment outside of using methane is we can use biofuels. We can use things that are grown organically or through the earth. We have corn. We live in a huge corn area with Illinois, Nebraska, Iowa, Indiana. It is a vital product for us. It does generate ethanol. Ethanol is an alcohol. Our vehicles can run on ethanol. If you ever go to the gas pump and you look at it, it will say 10% ethanol, 15% ethanol, whatever the case may be. So we are running our vehicles on alcohol. There was a idea there that we should be able to have a fully sustainable vehicle that runs purely on ethanol. And yes, that would be really great. However, what do people like to do with alcohol? They like to drink it. And so now we would have people that would just go to the pump and just start filling their bellies up with this elixir. So that's why they said, no, it's probably not a good idea, but we can put enough of it in there into our oil-based gasoline, and we can start to make things a little bit more eco-friendly. You also have to design the engine to be able to handle ethanol. So don't go up, filling up your vehicle with ethanol. Make sure that you have a vehicle that can handle the higher levels of the alcohol in there. Going off from ethanol, we have cellulosic ethanol. So we're using different parts of the plant, different plants to generate basically another form of alcohol for our vehicles and energy consumption. And then finally, we have biodiesel. Biodiesel is a form of fuel that we generate organically. So say you decided that, hey, I'm going to be making myself a nice big batch of French fries, and I'm going to cook with that nice vegetable oil or peanut oil or whatever the case may be. Well, what do you do with the oil after you're done? We dispose of it. However, there is fuel content still left in there. So what we can do is we can clean up that oil that was technically going to be waste. We can refine it and we can put that into an engine. It has to be a diesel engine. We can't run off of a natural aspirated gasoline engine. We have to use a diesel engine, the way the combustion process works and so forth. But biodiesel vehicles can run perfectly on vegetable oil. I've seen people that will literally go to restaurants, they will take all their oil for free. All they have to do is refine it. So these are just some of the examples of biofuels that we have out there. This leads us into other ways of saving energy, and that's through a building automation system. So most of the buildings that you may be working in are going to have some type of system like this, right? There's a lot of information, a lot of data points out there, and having a centralized system to be able to handle all this does make everyone's life much, much easier. So for example, if you have a heating and air conditioning system that's going to be feeding multiple floors, you may be able to look into there and get access into seeing exactly what's happening. So maybe on floor number 2, VAV box 15 is not operating. You can look at the different data points, the parameters, and then you can go and visually inspect and see what's going on. Maybe there's a stuck damper, maybe there's something happening that's causing that issue. Regardless, we've already got a place to even start looking, right? Otherwise, we'd be really guessing on seeing what's going on. So having a building automation system will control all the different points on there, your cooling system, your security, your lighting, and so forth. And having all that information, we can manage how everybody's operating. We can see different failure points, and we can reduce energy, right? We can decrease the temperature, we can increase the temperature, we can turn lights off when people aren't there. So we're all looking at different ways of maintaining that electrical consumption down to the smallest level that we can. And by also utilizing less energy, that means that we're not going to be using as much natural gas or coal or electrical or nuclear energy to generate all of our electricity, because those are the ways that we're currently getting our power. There are some solar panels, there are wind turbines and all that stuff. However, there's just not enough of them currently in our area, or even a lot of areas, to be able to be fully sustainable. So the output power that they generate makes it a little bit difficult. So we're still stuck dealing with coal or natural gas or nuclear as our main sources of power. Smart thermostats. I know we went ahead and we talked about those a little bit, as far as the ecobee. So the ecobee's a great, fantastic thermostat. One of the competitors for the ecobee is the Nest, right? You may see the Nest, and they've got a great marketing campaign that really makes everyone that sees the Nest want to jump in and get it. However, I do not recommend the Nest. The Nest is an awful product. There is some inherent design flaws with it. I don't know if the newer generation has been improved, but it's left such a bad taste in my mouth that I don't even recommend it to anyone. You ask any contractor, HVAC related, that's been in the industry for quite some time, they will tell you that the Nest is utter garbage. So just keep that in mind. Just like iPhone, everybody seems to have an iPhone, or there's some people that do have Android, but iPhone seems to be the winner when it comes to a lot of phones, and it's all about marketing. Google did a fantastic job of marketing the product, and they try to push that onto people. So not really that great of a thermostat, to be honest. So then this leads us over to utility load shedding. So what is that? So I don't know if you've ever seen it. Maybe you have, maybe you haven't. But I know California does it, and it's called, like, for example, rolling brownouts. So what happens is the electrical consumption levels get way too high. Everybody's running their air conditioning system. It's drawing so much energy, or powering their electric vehicle. There just isn't enough electrical output to be able to sustain all this. So what the electrical company will do is they will shut off parts of the grid, and they will let the other parts receive the electricity for their consumption purposes, and then after a certain amount of time they will turn the power back on, and they will shut down another part. And so you will have these homes that start to not have power, and that's just the problem that we currently face is with our electrical grid. We don't have enough output power to be able to sustain everything. Now you look at these giant data centers, we look at AI taking over, and the amount of electrical needs that these systems require is just outrageous. I mean, we're going to be surrounded by some type of power plant because of all the electrical consumption. The same thing goes for electric vehicles. Everybody's plugging in these things, and that's great. But where is the power really going to come from? And that is still one of those questions that we do not have an answer for. Everybody's just like, let's be green and so forth for the environment. And yes, that is great. However, let's look at the second question to that, and that is, where are we going to get the power from? And we haven't answered that yet. One of the things that the utility providers will also do is they will install this little box over here for you. That gets installed directly to the air conditioning system outside, the condenser. And what that does is the power company can remotely disconnect your air conditioning system. Let's just say it's really hot outside. Yet again, power consumption is way too high. They will remotely shut down the air conditioner because that is the biggest energy drawer. And by shutting it down, they'll let the energy levels decrease a little bit, and then once it's okay, they will switch it back on and shut somebody else off. And so they'll just do these little rolling brownouts or power outages, and you won't even realize it. Most people don't even know that their air conditioning system has been turned off because, hey, they're not out there. Maybe the temperature drops a few degrees and they don't even realize it. So that's just one way that the utility provider was turning things off. Well, they realize that people can be very snazzy in their things, and they can get provided discounts for their energy by putting the box on, but all they have to do is disconnect it, right? The wires are sitting here, they're dangling, they're doing absolutely nothing, and so it's all bypassed. So the energy providers decided that, hey, you know what we can do is we can install a smart thermostat, and that way we can control things on the back end. Most people don't realize this, that once the utility provider gives you that discount that they offer you, whether it's $50, 75, 100, there's a small little clause. You don't ever get anything for free. Nobody wants to give you things. In this case, there is a back door to that thermostat. The thermostat will not tell you it, but they will shut your equipment off temporarily. You won't be able to maintain the temperature or adjust it or do whatever you want. Because the utility provider decided that, hey, we are in a peak hour situation, and therefore we are not going to allow you to cool your home at the moment. You're going to have to wait a little bit. This is a Bosch outdoor unit, and the Bosch outdoor unit has this little gizmo that hangs on the side. That little thing right there is a cellular antenna. So now this thing has cell capability, and it's able to send data points directly from the unit over to the manufacturer. Bosch isn't the only one doing this. I know Mitsubishi still has some stuff on the back end that they're working on, but they're going to have capabilities from their perspective to be able to, if they want to, control the equipment, turn it off, and so forth. There's a lot of things really happening outside of our control that the big power players are trying to control the amount of electrical consumption out there, and this is just how they're doing it. So there are other avenues for energy conservation. The big thing is it's all based on ROI, right? Return on investment. So if it costs way too much to do and there's just not enough return, well then, hey, it may be not viable at this point. One example of that may be, hey, we want to replace equipment, but the equipment cost is $100,000 and we're not going to see that energy savings until it's 30, 40 years down the line. Well then maybe it's not a viable option at this point to replace it. But there are simple things that you can do to minimize the amount of energy loss. Insulation, for example, we can increase the insulation level inside of our attic space, maybe inside of our walls. Caulking and weather stripping. If we have a crack, right, that's air leakage. Sealing that off with caulk or spray foam or something like that makes a big difference. All right. New windows. We used to have single pane windows. Now we have double and triple, and then they're filled with gases that act as like a little insulator in between all that stuff. So this all has an effect on energy loss. We can't put insulation into the windows because then therefore we're not going to be able to see it. Windows tend to be the biggest energy losers out there. All the energy starts to escape through them, and so what can we really do? So like the double pane, the triple pane, those tend to be the best solutions if you have really old windows. All right, we have automated energy control systems, right? So going into similar stuff like the thermostats, we can regulate, we can automate, we can change different parameters inside of a building automation system, and that will help make things a little bit more energy friendly. The biggest one for us is the heating, ventilating, and AC systems, making sure that those units are maintained, making sure those units are fairly new, using as little energy as possible. That goes definitely a long way. Lighting. A lot of places they've installed LED lights already, and in the larger factories or places they do even have motion sensors. So if nobody's walking by these lights, well guess what? The lighting turns off, and therefore you're not wasting energy. In my experience, however, though, they do not work very well because it takes a while for the lights to turn on, or if you're not walking past them for a while, they shut off, and then you're working in the dark. So it's still a work in progress. Not all these ideas are very great, but it's where we're at currently. All right? We do have other renewable energy sources such as solar, wind, water, biomass, geothermal. There's different energy sources that are out there that we can capitalize and use. And then we already had discussed the energy recovery systems. All right. And what does this all translate to, right? It doesn't matter how much energy we save or we change or do. What it all definitely comes down to is human comfort. All right? The body at rest and in surroundings of 75 and 50% relative humidity with slight air movement is normally comfortable. So what that means is if the humidity is 50%, 75 degrees in the space, we're going to be pretty good. So, So let's go ahead and look at our chart over here. If we go ahead and we take into account our relative humidity, yet again, our example was we take 50%, we scroll it over, and we look at 75, it's going to make an equivalent of 70 degrees in that space, right? So that's ideally what we're really feeling with that humidity level. Well, why does humidity level make such an impact, right? Maybe from your previous classes you learned, but humidity does have heat content inside there. Think of an 80-degree day, 100% humidity, we're going to be pretty darn uncomfortable, right? 80-degree day, no humidity, a lot more comfortable. So there's that heat content. So understanding where the heat content is with the humidity level is going to make a big difference as far as what our comfort is based on the our skin perceiving temperature differences, right? And so staying within this nice blue chart right here is going to make things the most comfortable and effective for us and our customers. So we're always looking to maintain temperatures in this environment. And so that brings us to the end of our first chapter. Hopefully you guys learned some information here. If you do have any questions, make sure you do email them to me, and I will go ahead and discuss those with you in a timely manner. I think next week we will go ahead and we will start to discuss building science.